Getting into amateur radio can have its challenges. A lot of time and effort is spent on exams, collecting equipment and setting up the antennas. Sometimes it's nice to set up a station in a quiet location. It's great to assemble the essential parts and look forward to hearing the stations from around the world. But sometimes, all you get is noise. We're surrounded by noise. It can be hard to find. When strong noise appears, your station can be pretty much useless. It's a big relief when you finally track it down and make it stop. The first step to finding out where the noise is coming from is to study it a little. Is it there all of the time? Is it linked to a particular time of day? Is it coming from your own home or from somewhere else? But noise can be pretty elusive. Every type of noise has its own unique sound and profile. Static from power lines will sound a little different from, say, a bad thermostat in a fish tank or a poorly filtered power supply somewhere. One of the important attributes of radio noise is how far it penetrates up the frequency spectrum. The closer you are to the source, the higher the frequency can be heard. Here we can see a spectrum analyzer listening from around 1 to 200 MHz and a small receiver tuned to about 10 MHz. This 50-watt LED flood lamp is a particularly noisy source. See how the noise penetrates halfway across the screen, deep into VHF frequencies. When we pick up the lamp and move it away, the interference reduces intensity, but it reduces from the highest frequencies first. At about 25 meters, the noise only affects the bottom end of the HF band. Trying to work out how high a noise source reaches and how the highest frequency changes with distance is an important part of working out where the noise is coming from. Before we can track down any noise source, we need to prepare the tools that will help us. One of the key tools to have for tracking down interference is a simple coax loop antenna connected to a portable receiver. Over the next 5 minutes, we'll be showing how to build one of these antennas from basic parts. We need a short section of RG8 or RG213 coax, a couple of PL259 plugs, a T-piece adapter, some heat shrink tubing, and a few hand tools to put it all together. We need 900mm of this cable marked off in two 450mm sections so that we get to mark where the centre of the cable is. For our purposes, the cable doesn't need to be new. A section of old scrap coax cable would be fine. Slide the small section of heat shrink tubing onto the cable now, as it has to be in place before the connectors are screwed on. Using the length of a PL259 plug as a reference, cut away the outer protective sheath. Now we can bunch the copper braid back onto itself and trim back the excess braid. This leaves the end of the centre core exposed. We must remove about 20mm of this centre core insulation, but the nylon material can be very tough to cut even with a sharp knife. Sometimes it's better to remove it in small sections, as we don't want to break the centre conductor strands as the insulation is cut away. Next, separate the two halves of the PL259 plug. Slide the outer part of the plug over the cable first. Then the rest of the connector can be screwed on firmly to the thick braided copper. The tip of the connector must be soldered, leaving no protruding bumps on the centre pin. The outer part of the connector can then be restored. Now we must find the centre of the cable where it was previously marked and measure about 10 mm either side of this spot. With a knife, score around these two marks and carefully remove the outer sheath of this 20 mm section. With a good pair of side cutters, cut away the copper sheath inside the exposed area, ensuring that there are no loose strands left behind. When this centre core has been completely exposed, it's time to seal this area with a heat shrink tubing using a hot air gun or radiant heat source. We move on to the second PL259 connector, as before sliding the outer part onto the cable first, then trim away the sheath and the braid as before. An important difference with this end is that the centre conductor is not terminated, we are just going to cut it off. Then we can screw on the rest of the plug. With a pen or even coloured tape, mark this end of the cable. Now we are clear to form the loop onto the T connector and the antenna is complete. With the receiver connected to the centre of the T, we have created a non-resonant balanced loop that will produce a decisive null in the interference signal when it is held 90 degrees to the noise source. For best results, the receiver should allow the operator to listen to the bottom half of the HF band using an AM receive mode. Somewhere around 10 MHz is usually fine. This tool will greatly simplify the process of identifying the location of any wideband interference. That's all for today. In the next video, we'll be showing how to use this antenna to find a variety of interfering noise sources.